Space is vast, extraordinary, fascinating, and even a little terrifying. Many know what stars, planets, galaxies, and even black holes are. However, there are many strange and weird phenomena and objects which are unknown to most. In this video, I'll present a couple of them, and by the end of it, I hope you'll be even more curious and fascinated about space. When a star dies, many things can happen. If the star is not massive enough, let's say it's the mass of our sun, a mere 2 times 10 to the power 30 kilograms, it will become a red giant and then a white dwarf. However, if it's very massive, about 10 to 25 times more massive than our sun, then when it will die, there will be a big explosion, which we call a supernova. When the supernova happens, the core of the star collapses on itself. If the core is massive enough, it becomes a black hole. However, if it isn't quite massive enough, a neutron star will form. So, the core is made of atoms, and atoms are made of neutrons, which are neutral, protons, which are positive, and electrons, which are negative. What happens is that when the core collapses onto itself, the protons and electrons, they get so close that they become a neutron. Neutrons don't repulse each other, and so they can be really close. So we end up with the core being made of a bunch of neutrons, and that is why the neutron star is called the neutron star. However, it's important to mention that the neutron star is not completely made of neutrons. On the outer layers of the neutron stars, there's actually still some protons and electrons. It's as we go towards the center of it that there are more and more neutrons. So, why do we care that there's a bunch of neutrons close together? Well, that makes the neutron star extremely massive and dense. In fact, it's 1.4 times the mass of our sun. And you might say, well, that isn't much. And that's true. However, the thing is, neutron stars are only about 20 kilometers in diameter. That's not even the size of a big city. It's only like a small city. Here's an image of a neutron star compared to Montreal's island. And just to remind you, here is an image of the Earth compared to the sun. And yet, a neutron star is more massive than the sun. That's crazy. This means that neutron stars aren't only dense, they are extremely dense. If we ignore black holes and their singularities, they're the densest objects with the strongest gravity in the entire universe. In fact, as mentioned in a Kurzgesagt video, a cup of coffee of neutron stars would be about the same weight as Mount Everest. And that would mean that a tablespoon of neutron star would weigh 1 billion tons. In comparison, 1 tablespoon of sun would only weigh about 2 kilograms, the weight of a light laptop. In fact, a neutron star's gravity is about 2 billion times stronger than on Earth. That would mean that if I were to stand on a neutron star, I would get instantly flattened into mere particles. Ouch. A fun fact about neutron stars is that they spin extremely fast. Also, they have very strong magnetic fields, which are trillions of times stronger than our own Earth's magnetic field. Also, at the poles of these magnetic fields, there are funnel jets ejecting particles which can be observed. So when we observe a neutron star, because it spins, we only see the jets at certain frequencies. So it creates a pulse. We call those neutron stars pulsars, and in a way, they act like the lighthouses of space. Also, neutron stars with especially strong magnetic fields are called magnetars. Magnetars are the objects in space with the strongest magnetic fields. A very interesting thing about neutron stars is that two neutron stars can orbit around each other, and if they're close enough, they spiral down and collide. This creates a big explosion called a kilonova. What's interesting is that we don't really know what happens after that. Some say a big neutron star is created, and some say maybe even a black hole is created. What's also interesting is that this kilonova explosion creates heavy elements with a lot of protons and neutrons, such as gold, uranium, and platinum. This would mean that you probably in your life came into contact many times with particles that are from two neutron stars colliding, and you may be even made of some of these particles. That's pretty cool. We'll now move on to a much bigger realm. In fact, we'll talk about the structure of the universe itself, the cosmic web. When you think of the universe, you probably think that galaxies are just randomly placed in it. However, that's not really the case. In fact, since the Big Bang, due to many complex phenomena and gravity, superclusters of matter were formed. These superclusters are basically places where matter is all gathered together. So for example, billions of galaxies all close to each other. In between these superclusters, there are what we call voids, which are mostly empty spaces. What links these superclusters together are called filaments, made of mostly dark matter and gases. We'll get to dark matter later. This creates a web-like structure and almost makes the universe seem alive, slowly expanding its reach. But there's probably still a word that I said earlier on that you remember. The word void. A void is empty and is even a little scary. We might wonder what it's like in a void compared to the lively superclusters. The thing is, we could be in a supervoid right now. It is believed that the Milky Way is in one of the biggest, if not the biggest, currently well-known supervoids called the KBC void. This void has a diameter of 2 billion light years. However, don't worry. Most regular voids are only about 30 to 300 million light years in diameter. Not too much. Also, our galaxy is not completely at the center of the void, but more at the edge. But still, this means that voids aren't actually empty, as we just saw. The KBC void has our own galaxy in it, and many others. It's just the fact that compared to superclusters, voids have much less matter. The density is much lower. It's hard to imagine, but it's really looking at it from a large scale perspective. Even if our galaxy is surrounded by many galaxies, compared to superclusters, it's maybe not that much. Well, that's enough about voids. Now, let's talk about some interesting facts on our universe's structure. The biggest filament in the universe, and also the biggest quote-unquote official structure, if we ignore the cosmic web, is the Hercules Corona Borealis Great Wall, which contains billions of galaxies and has a length of 10 billion light years. So we talk a lot about billions of light years. We mentioned the KBC void, which had a diameter of 2 billion light years. In fact, the observable universe has a diameter of 93 billion light years. But how does it compare to some more imaginable distances? Well, the diameter of the Milky Way is about 100,000 light years, and the distance from our Sun to the nearest star, Alpha Proxima Centauri, is only about 4.2 light years. Now, this really shows how the scale of our universe is much, much bigger than the scale of our own little close star and planet system. Another really interesting thing is that researchers at the University of California at Santa Cruz, Joe Burchett and Oscar Ellick, used a slime mold algorithm based on the mold Physarum polycephalicum, which is a mold that finds optimal food pathways and has a web-like structure, to create a computer model of the cosmic web. They gave to the mold algorithm data of galaxies' locations and observations from the Hubble Space Telescope to create that model. However, I cannot talk about the cosmic web without explaining dark matter. The cosmic web wouldn't exist without dark matter. In fact, if there was only observable matter, the gravity exerted by this matter wouldn't be enough to create galactic clusters, which are essential to the cosmic web. And that's where dark matter comes. Dark matter doesn't interact with the electromagnetic field, which means it doesn't reflect or emit light. We cannot directly observe it. However, it does interact with gravity. This unobservable matter would compose, in fact, 25% of the universe, with normal observable matter composing 5% of the universe and dark energy composing 70% of the universe. So there's actually more dark matter than regular observable matter for the structure of the universe to work. So dark matter is mysterious. We don't really know what it is. We never directly saw it as we can. Maybe it's some mysterious particle or something else. We don't know. However, we were able to see its existence due to its effects. In fact, large pools of dark matter have strong gravity and bend light. Because it bends light, we can observe the presence of dark matter. Sadly, dark matter is not some sort of sci-fi, multi-dimensional, weird substance. It's really just matter that cannot be observed and that is needed for calculations to work. Of course, there are many space phenomena which I haven't discussed but which are just as fascinating. For example, there are the stunning quasars. A quasar is a supermassive black hole at the center of a galaxy which is surrounded by a whirlpool of plasma the size of our solar system and which ejects jets of particles. Quasars are extremely powerful and are the brightest objects in our universe. In fact, they even outshine galaxies. We could also think about dark energy, which composes 70% of our universe and is responsible for the acceleration of its expansion. Heck, there's even the mighty eye of Sauron, gazing at us 25 light years away. So, thank you for watching. I hope this video made space seem even more fascinating and interesting. The sources I used to find my information, I've put them all in the description down below. I've also put all of the links for the images I used, and I've also put the name of the songs for the music, which are all non-copyrighted. Thank you for watching.